In this lecture, we're going to learn another way to find the equation of a line, provided that we're given different pieces of information. Earlier, we have learned to find the slope by using 2 points that belong to the line. Then, we also learned to find the equation of a line provided that we had a point and also another line which was parallel. This one is slightly similar. The difference here is that we're given another line which is perpendicular to the one we want to find. We have a point, in this case -5, 11, and we have another line which is perpendicular to the one we intend to come up with its equation. So, what you have to remember is that the equation of a line can be found like this. If you have a point and the slope, then you can find the equation of that line using this formula. We do have the point already, -5, 11. We're just missing the slope. We don't quite have it yet because we don't have 2 points. If we had 2 points, then we would use the slope formula. If we knew this line were parallel, which was the previous lecture, then we know the slope is -4, and it's precisely the same slope because the y is isolated and parallel lines have the same slope. So the difference here comes with this word, perpendicular. So for that, we're going to use another small formula or a trick, if you will. So now, there is a slope you already have, which in this case is -4. And there is a slope that you want. Let's call it like this. Slope you want, it's going to be -1 divided by the slope that you have. By the slope you have, I mean this one. The slope of a line that is perpendicular to the one you want to find. And here is the one you're going to compute using this. And it's always going to be like this, -1 divided by the slope you have. How do I know when I'm supposed to use this? When you have this keyword here, perpendicular. So let's do it with this exercise. It becomes -1 divided by the slope you have, which is -4. We know that's the slope because the y is isolated. If it's not, we have to do it. So the slope you have is -4. So be careful, this negative is from this little formula here for perpendicular lines, and this -4 is from this particular exercise because that's the slope we have. So be careful there, we have 2 negatives, that becomes positive, 1/4. And that is the slope we're going to use in this formula here to find the equation of a line that meets all of these conditions. So y minus y1, which is 11, equals the slope we wanted, which is 1/4. As usual, the parentheses x minus from the formula here, x1, which is -5. So be careful, there is a negative from the formula and there is a negative from the point we were given in the problem. So y minus 11 equals 1/4. -5 becomes x plus 5. Then y minus 11 equals 1/4 x plus 5/4. And the remaining steps are quite simply isolating y, which is almost ready. We just have to move that -11 to the other side of the equation, but this time positive. And then we just add like terms. So -11 comes here as +11, and we have to add up 5/4 plus 11. So 5/4 plus 11 is quite simply 49 divided by 4. And that would be the equation of a line, like it says here, parallel or perpendicular actually to y equals negative 4x plus 1, and that goes through this point. Now, if this step is not quite clear, you should post your comments on it, and that could become a lecture on this course. But here we just cross-multiplied, and that's how we found 49/4. Okay, that would be the equation of the line. So as an exercise, go ahead, do the quiz, and also write in the comments examples of perpendicular lines. To figure out they're perpendicular, you just have to check that the two slopes of the two different lines meet this condition or this little equation.